VeriStand today supports many environments in importing models and being able to execute them on the CPU of our controllers. So when we look at the MathWorks Simulink software, it's one very common in industry today. Over the past several years, NI and the MathWorks have collaborated together to improve that integration piece. It's also alluded to being able to facilitate an easier transfer of models into a Hill environment is vital, just so we can allow the test engineers to really focus on developing test sequences and being able to validate the actual embedded software. In addition, we support LabVIEW models, being able to generate them, as well as being able to import models from a variety of environments that support the FMI 2.0 standard. In VeriStand, it's a pretty straightforward process of being able to just take that compiled binary from any of these environments, being able to import and deploy down into the real-time target where the VeriStand engine will appropriately execute that model. To demonstrate this, I'll start by jumping into the Matlab environment, and I can show how we can actually compile a Simulink model and then eventually bring into VeriStand. So we have here, within the past 2 years, we released a new toolbox that's natively available in Matlab called the VeriStand Model Generation Support add-on. I can get this add-on directly from Matlab's site, as well as be able to reference documentation natively in the application. What I'll show here today is an example that we prepared. It's a fairly simple engine demo model that at a high level takes in a command or a desired RPM, a command to turn an engine on or off, and outputs the physical actual RPM as well as an engine temperature. In between these stages, we have a couple of subsystems that kind of transfer that calculation throughout. So fairly simple. The nice thing about our toolbox is it's designed to allow the user to not really have to make any modifications to their model to be able to compile it and bring into VeriStand, rather than have to utilize, say, custom I/O blocks for our environment. So what we can do from here is I have my model. I can go into my model configuration parameters. I already have a saved configuration. So we have a system target file, our VeriStand TLC, which is derived from Simulink's generic real-time TLC. I can select my tool chain. I'm targeting an NI Linux RT target. In addition, I can set a variety of settings up here for my simulation time. In this case, I'm just using a fixed step size of 0.01 seconds. So with this, I can either build, and I can start monitoring now from the diagnostics window. That process should be fairly straightforward for a model this simple. And I can actually see I have my built output. If I go back into Matlab, I can see here I have this new file, an enginedemo.vs model. And that's the file that we're actually now going to move over into VeriStand to import and deploy. So I'm now in VeriStand. I have a project that I had developed previously just to save time for this demo. And I already have my engine demo model. Just to reiterate how to actually add this in VeriStand manually, I can come over into my editor, select the simulation model node, drop that on the diagram. I can go and select my model. I compiled a specific Linux VS model. That's where I'm going to be deploying it. I can import that by default here. I can see my different channels that are imported by default, as well as I can select parameters that I may want to add. In this case, like I said, I've already added it. I have some different formulas and channels connected to this. Going to come over to my screen as well. So I've pre-designed a screen here just to show how I can deploy this model, start an engine, maybe run through a basic sequence here. So before deploying, I'll save. I'm going to deploy now to my Linux RT target. It's going to take a few moments to deploy all these files. And we'll start up the engine. I can monitor the output in the VeriStand environment. And we should be starting now. So I am connected. By default, I don't actually have my engine running. So if you remember for the model now, like nothing's really going to be changing. Before I start, let's say I just want to set my desired RPM to 5,000. On my chart here that's monitoring, I can see my desired RPM spikes up to 5,000. My engine hasn't started, so I don't actually have an actual response yet. I can click that on button. Now I can start to see that ramp up. I'll likely overshoot, as you may expect in a realistic model here, my desired before returning to the desired. And just to show, if I turn off my engine, I'll see my actual RPM plummet back down to 0 here. So that's just a simple case of demonstrating importing and executing a CPU model